Today I'm going to present on the topic of population growth and holistic development of states. So it is not new for me, and I think it is not new for the scholars of population studies as well. So present it a bit in modified version. I guess I want to make a very new research, and I just want to let you all that this is the topic I have selected for my PhD research as well. And the area of the study is, as topic indicates, that relation of population growth rate and holistic development of different countries of the world. I just want to let you know that I'm going to do inter-country comparison. It's not about within a country, it's inter-country comparison, and I have selected that kind of data. So just I kindly request to keep this in mind during this whole presentation. And after that, there should be some theory which justifies the selected topic and the selected research. And I just want to mention that the most fundamental concept of this study is that historic growth of population in 20th century. Being a population studies scholar, we often keep on discussing about this topic because it reached for the first time 2 billion around 1930s, 4 billion growth in population during 20th century only. And this is a massive increase. That's why this is the very fundamental theory or context of this study, how population growth interacts with other development indicators. That is the basic context of this study, and it has different visible and invisible impact in human living environment, and that growth is still continuing. That is the matter of concern. In 21st century also we have seen, so it is very relevant to study. After that, while population was growing like this, there were different development theories also developed and defined. I just want to let you know that I have used multivariate analysis of various MONOVA approach for this purpose, and secondary data I will be using. After that, these are the variables. Independent variables is population growth rate, which is by nature continuous variable, numerical continuous variable. But I have converted that into categorical variable with 3 levels, that is low population growth, which also include the population growth, which we say 0 or there is no increment, or negative also. For the country like Japan, it is negative population growth. Similarly, another is moderate population growth and another is high population growth. I will be examining these 3 levels of independent variables relation with 6 dependent variables. Which are all numerical in nature, a continuous variable, because MONOVA demands this, and the variables selected are basically from HDI. 3 indicators, they are life expectancy, mean years of schooling, and GNI per capita. Actually there is another indicator also in education, but I have taken mean years of schooling here. When I went through the literature and I found some gap there, and as per that I have added other 3 variables, that is unemployment rate, GHG emission, that is greenhouse gases emission, which is related with the fossil fuel consumption and everything. And this is primarily I am thinking to observe only carbon dioxide, because that is the major GHG which is contributing in global warming and everything. And after that, the last one is expenditure in research and development. These are the variables. Now I am going in the main research question, which sir is also demanding. My main research question is change in population growth is associated with holistic development of countries. Similarly, another research question, to what extent does the population growth affect holistic development of states? To what extent? Your focus is. Another is, what kind of population growth is beneficial for holistic development of states, because this is very relevant for like policy makers at state level and international level, because while forming population and development policies, it is very unanswerable question till now, what kind of growth there should be. So I am taking this as a one question. Which development indicators are positively affected by population growth? And similarly, another question is, which development indicators are positively affected by low or zero population growth? Well, these were the very general questions for broad research area, but there are some variable wise research question also. Actually, I just have to mention here that in MONOVA, what happens is, we can observe the relation between independent variable and one single dependent variable also. That's why these questions are formed accordingly, but I'm not going to all questions, but just I'm going to first question only. Is change in population growth is associated with life expectancy at birth of countries? That was the first out of 6 variable, it was one variable, and this question is for that. Accordingly, I have made 6 questions for 6 variables. After that, I am coming to hypothesis. The first condition is that we are going to test the overall hypothesis. That is in MONOVA model. Like there are some tests called post hoc tests, which tests individual hypothesis as well. It automatically gives the F statistics for individual hypothesis. That's why I have developed hypothesis also accordingly. So I am sharing that also. The main hypothesis is population growth is not associated with overall development of countries, or it can be rephrased like that. Overall development of countries is same across different population growth rates or levels, or it can be rephrased by other way also, by specifically also, but I have given a bit general statement here. And after that, alternative hypothesis, population growth is associated with overall development of countries, or overall development of countries isn't same across different population growth rate. As I already mentioned that I have developed variable wise hypothesis as well. And for first variable, that is life expectancy, the null hypothesis is population growth is not associated with life expectancy of countries, or average life expectancies of countries is same across different population growth rate or levels. Alternative hypothesis is population growth is associated with life expectancy of countries, or average life expectancy of countries is not same across different population growth rate levels. This is the alternative hypothesis for one variable, and similarly there are other hypotheses for each variables. I'm not going through them, but they are there. And as I mentioned earlier, we can perform MONOVA. Actually, this is performed by software automatically. Reports are given there. We just need to interpret them. Methodologically, it is possible, and theoretically, it is very useful. As I mentioned in the gap part of literature, that other variable rarely have been discussed relating with population growth. That's why it is very, very important. Now, I want to go in Wilks test. Actually, it is similar to F statistics. It compares with sum of squares to the total sum of square. In that sense, it is very similar. It is sometimes interchangeable with the term like likelihood ratio. And similarly, another is Roy's test. It is also called Roy's union intersection test, or Roy's largest root test also. And among those 4 tests, it is considered as the most powerful, but it is not flexible towards assumptions, because if there is violation of assumptions, it is not useful much. And another is Pillet's test. Among those 4, it is considered as relatively weak, but it is useful because if there are some violation assumptions, but still it is performed. So this is the benefit of this test. Another is Lolly-Hotelling test, and this is also called Hoteling's generalized t-square statistics, and it is often paired with Pillet test in many of the book, including which I presented earlier. And after that, this is one of the very important topic to discuss while performing MONOVA. Because of this very reason, many researchers don't want to perform this test, or they want also, they cannot, because of not meeting these assumptions. Generally, it is considered as it is robust against non-normality and heterogeneity of covariance. In case of Roy's test, these assumptions should be made very clearly. As in the many other statistical tests, it needs independence of observation, which is ensured by random sampling. And after that, multivariate normality and outliers. Actually, this is required to avoid type 1 error and to avoid type 2 error. Type 1 error we make by rejecting the null hypothesis, and type 2 error we make not rejecting the null hypothesis, though we had to. So this multivariate normality and multivariate normality, not only normality of a single variable, it should be multivariate. And if there is any outliers which affects the p-value, that's why we need to be careful on that. After that, homogeneity of covariance. This is particularly ensured by Box's M test in SPSS. If there is no linearity condition met, we cannot perform this test. For example, if there is curvilinear relation between variable, this test doesn't fit there, because there should be different different kind of process for that. And for this, the simplest way is to color scatter plot. We use, in case of bivariate, simple scatter plot, but here are multiple variables. If we use colored scatter plot, then we can see how they are related in different colors. So we will not be confused with the relation between variables while visualizing. After that, we have to also see on this assumption, that is multicollinearity. That is, if there is any kind of multicollinearity, then we cannot, if that is very high, 0.9 or 0.99, then we cannot perform this test. That's why if there are some variables and we can identify which are multicollinearing with other variable, we should omit them from that model. So this is what are the assumptions about MANOVA. And here I come to the end of my presentation, and here are list of literature which I use for this study. And thank you, sir and everyone, for listening me till now. Now I want feedback and questions if there are any.